In the previous part, we covered singly linked list, and now we are going to cover doubly linked list in Python. So, what's a doubly linked list? A doubly linked list is a linear data structure that consists of nodes where each node contains two pointers, one pointing to the next node and the another pointing to the previous node. This structure allows traversal in both directions, making it bidirectional. Means in doubly linked list, we have two pointers. One is this one, previous, it's pointing to the previous node, and this one is pointing to the next node. This is our head part. And as we can see in singly linked list, we just have next pointer. But in doubly linked list, we have previous pointer also. And by adding this previous pointer, it allows us to traverse the linked list in both directions. Since we can traverse in the left to right manner and also in this right to left manner using this previous pointer. Here is an example of a doubly linked list from Scalar. This part is our data part, and this one is next pointer, which is pointing to this node. And in the next node, we can see here we have the previous pointer, which is pointing to the previous node, and its data part, and the pointer for the next node, which is this one. And next pointer of last node is pointing to the null. So without wasting time, let's get started with the coding part. Let's start. First of all, we have to create a new file. We can reference this linked list, singly linked list also for creating our doubly linked list. So let me just delete it. Okay, so in doubly linked list, same as singly linked list, we have to first create a class node. In doubly linked list, we have data pointer, next pointer, and a previous pointer also. So let's just write self.travel call and assign its value to none initially. Okay, after this, we are going to create our doubly linked list class. I am just naming it dlinked list. Inside our class, we have to define an init method and pass the self.head value to none initially. Okay, now let's come to the functions. As you can see here in singly linked list, we have insert at start. So we can do the same for doubly linked list. We can also create this for doubly linked list. Let me just copy, paste it there. Now what we did is, first of all, we created a new node, and after that we are assigning the new nodes next to self.head. You know that self.head will point to the start of node, and if we have to insert a node here like before it, then what we can do is we have to assign the next of our new node to self.head, which is the current node. So our new node will be inserted here, and its next will be this one. After that, we can just do self.head equal new node. Then ask the head to the first node or the newly created node. And also we have to check one more thing in case of doubly linked list. Like if our self.head is not null, then what we have to do, we also have to assign the previous pointer of our node which is present at head to point our newly created node. Since if a new node is created here and initially we don't have self.head none, since we have some node present here, then we have to assign the previous pointer of that node, which is this one. to our newly created node, which we created just now. After that, we have a function insert at end for singly linked list. We can do the same for doubly linked list. Okay, so here what we are doing is we are just creating a new node. Then if our linked list is empty or head is at none, then just set the head to new node. And otherwise, what we have to do is we are creating a temporary variable current head with self.head value, and we are iterating through our linked list using this current head equal current head dot next until we reach the current head dot next value equal to none, means until we reach the end last node of our linked list. So after reaching the last node, what we are doing is we are just passing the current head dot next pointer value to newly created node, and as it's a doubly linked list, we also have to set the previous pointer of our new node to this current head, which is the last node initially. Let's see by example. If this was our last node and we are creating a new node at the end, then we also have to assign the previous pointer of this node to the previously considered last node. This will complete the linking for our doubly linked list. And after, so what we did here is when we created a new node here, and we have to pass the previous pointer of this newly created node to the last node that we considered earlier. And after doing that, this will complete the linking for our doubly linked list. After that, we have insert after. So for creating insert after, just write define insert after self. We need data and a previous node also. Why we need this previous node? Because in doubly linked list, let's say if I know the value of the previous node, let's say I want to create a new node between these two nodes, and if I know the previous node value, then I can simply insert a new node here by just setting the next pointer of this linked list to our new node and the previous pointer of our newly created node to this previous node. Also, if we have more values, like if we have the next of this previous node not equal to none, means we have some node after this previous node, then we also have to set the previous of this next node to our newly created node. So to do this, first of all, similar to the singly linked list, we have to check whether the previous node is present or not in our linked list, and if it's not, then we are going to return from here itself. Otherwise, we have to create a new node, and after creating the new node, we are setting the new nodes next to the previous node dot next. Just pass the previous node value here, and after the new node is created, we have to pass the new nodes next to this previous nodes next. It should be previous node. The new nodes next pointer is set to previous nodes next. Means if we are creating a new node here, then it's this previous nodes next, which is 1004 in this case, will be set to the next of new created node, new nodes next. We will do this step later. First of all, what we have to do is we also have to assign the previous pointer of newly created node to the previous node, and when it's done, we have to check if there is a node after the previous node, So we can check it by passing if previous node dot next. We have to set the previous node's next dot prev. It's this value. This previous node's next dot prev. We have to set this value to our new node. After that, we just have to set the previous nodes next to our newly created node. So that's all for insertion and after. So our insertion methods are complete. Now let's try to run them and show our linked list values. So first of all, just use this print function to print the values of our linked list. Let's create a new linked list. I'm naming it as L. A linked list, and after that save it and run it. So we can see that first of all we created a linked list, and after doing inserted start, it's creating a new node at the start and its value is 10. After that we are inserting at the end. After that we are inserting after. Here we are inserting after the second node. So this one is first, second, and after that we inserted our new node here. Then we are inserting at start 60, 70, 80. So 64, 70, and then we are inserting 80 at end. So it's inserting at end. Our methods are working fine till now. Let's add some more methods. And also initially, as I told, that we can reverse the linked list in forward manner also and in backward manner also. Here in doubly linked list we can also create a method. Just name it let's say print backward. This method is going to print our node's value in reverse manner, means the last node will be printed first and fill the first node in this null pointer. To do that, we are similar to here, we are creating a temporary variable whose value is at self.head. So in case of doubly linked list or linked list, you know that our head is always at start. You know, we can't just traverse the linked list randomly. So first of all, we have to create a temporary variable for head, and we will have to reach the end of linked list initially. And after that, for printing, we will be printing the data value one by one, and we will be coming to the previous node and then print its data and so on until we reach this null value. So this is the way how backward traversal is done in doubly linked list. So the first step for traversing till the end will remain same. So let me just copy and paste it down here. And as we are not going to print anything while traversing from left to right or while reaching the last node, so just cut this out. After we reach the last node, what we can do is just use while current head, means while current head is not none, we just have to print our value for current heads data and just iterate backwards. So in case of iterating in forward, we are using the next pointer. Here you might have guessed that we have to use the previous pointer for traversing backward. And that's it for our print backward function. Let's try it out, save it and run it. Oh, It's showing none. So what did I do wrong here? Oh, okay, I got it. So here you can see we are checking if current head is not equal to none, and if it's not, let's say in the case of last node we reached our current had reached the last node, then we know that its value is not none, so we will enter this while loop, and we are setting our current head value to the next. So if it's our last node, then the current head value will be set to none, and while we are checking current head, so this while loop will not gonna run because it's already current head is at none. To fix it, we just have to say that while current head dot next not equal to none, and we also have to check whether the current head is present or not. So just do while current head and current head dot next not equal to none, or you can just say while current head and current head dot next, since these two are not none. And if I save it and now run it, okay, yeah, you can see that it's printing in backward. First of all, it's gonna print this last node's value, then 40, 20, 10, 60, 70, and none. So it's working perfectly. Now we are remaining with one more important method for doubly linked list, which is the delete method. So to delete, similar to linked list, we can delete the node by checking its key or its data value, and we have to create a temporary variable for self.head. After creating this temporary variable, we have to check if the current head dot data is equal to the key which we want to delete. Then, but since we found the node that we want to delete by checking its key, now for deleting, what we have to do is, first of all, we will be checking that whether this current node is having any previous node also. So if we current head dot previous, why we are doing it? Let's say we want to delete this node. So how we can delete it? We will be assigning this next pointer of this previous node to the next node, which is this one. So we will be setting this next pointer of this previous node to this next node, and the previous pointer of this next node to this previous node. So our new linked list will have only these nodes, this one, and this one. So if we have a previous node, we are just passing the previous node next pointer value to value as the current head's next node. We don't have a previous node or its previous value is none. Then just assign the self head to current heads dot next. Why we did this one? Because let's say if we are going to delete this first node or the starting node, then we don't have any previous node for this node, and if we want to delete this one, then we have to pass this head value to here. So our linked list will be starting from here. That's what we did with this line, and this is for previous node. And similarly, we have to check whether our current head has a next node also. If that's true, then we have to pass the previous pointer of current head's next node to current node's previous value. After that, we can just use delete current head to free up the space used by the node at current head, and just return from here. Current head's data value is not equal to key, then just increase the current head or assign to Next, that's it for delete method. Let's try it out. Just use delete, and let's say I want to delete this 10 data value. Just do this and then print the linked list. After running, you can see that this node with 10 value got deleted from our linked list. We can also check if the data of the node which we want to delete is not present in our linked list. Then we can just see that, and let's try this one also. Just pass some random value which is not present in the linked list. I'm passing 100 and trying to delete it. Okay, so it says that node with the data key you gave is not found, and it's just printing the linked list here. So that's all for the doubly linked list. We had already covered the main functions for doubly linked list. You can also try other functions like checking the length of linked list and checking if it's empty or not, or some other functions. So that's it for this video. I hope you learned the concept of doubly linked list, and if you liked the video, please give it a like and subscribe to the channel and put your doubts in the comment box. Thanks.